Okay, so good afternoon again, everyone. Welcome to APNIC eLearning web class. Today is the 18th of May in 2016. It's 1 o'clock in the afternoon from Brisbane in Australia, where I'm broadcasting this class. And this is already the second session that we are conducting for the day. If you have attended the previous session, that's 11 o'clock, we discussed about IPv6 addressing. So this one is a logical next step to that session. This session will be called IPv6 Address Planning. So we'll go through a lot of ideas on how you can use IPv6 addresses that you already have to then plan for the allotment, deployment to different parts of your network. Depending on your situation, of course, it will be a little bit different. But I know that this session has been helpful to a lot of people because the main question that they have coming into, say, a class is they already have an IPv6 address. They were able to obtain it from the RIR. And the next question is, what are we going to do next? What is the next step for us? So in this session, we will go through that. Now, very briefly, I just want to introduce myself for those of you who haven't attended any of my sessions yet before. My name is Cheryl Hermoso. I work as a training officer for APNIC. So I'm part of this training team that conducts face-to-face workshops and then different e-learning sessions as well to different members of the internet community. Okay, we have some echo on one side. Let me just check the audio. Someone will check the audio from our end quickly. Let me know if there's still an issue. Otherwise, I reckon it's okay. It's clear with some other people. So also check from your side whether you can fix it by making it louder, I guess. So sorry about that, Francis. Is it a little better now? Okay, I'll continue speaking and then let me know whether you're still having any issues. Okay, that's good to hear. Okay, as I've said, we do conduct different sessions about internet technologies to the members of the internet community in the Asia Pacific region. So different topics like network security, IPv6, DNS and DNSSEC, internet resource management. I don't put there, but we do routing, BGP, MPLS, and all those sorts of things as well. Now, brief reminder, this class runs for 1 hour, and at the end of the session, we'll be asking you to fill in a survey, and I do hope that you fill that in because that's very important for us. Your feedback will be used for us to gauge whether we have been doing this effectively or not. Okay, so what are we going to discuss this afternoon? Maybe it's still morning from your end. A few things, okay, for those of you who attended the session earlier, there are some overlaps because I want this to be an independent course by itself. So we have a bit of a review on IPv6 addresses. Or specifically, where do we get these IPv6 addresses from? Okay, and from there we will continue with looking at two different scenarios, different case studies on using these addresses given, say, a /32. How do you plan your network? So these case studies are one for an ISP infrastructure. Okay, most of you, if you're working for ISP, this might be a good starting point for you. And then another one is some guidelines if you are a customer. We have some case studies and examples for both of these scenarios. Okay, we will look at how we did the IPv6 addressing, how we subnet for each of them, and what are the different considerations on those decisions. At the very end, we have just, I think, 1 or 2 slides discussing about IPv6 addressing tools that you might find helpful for your case if you don't have one yet. Okay, so let's proceed with the first part, which is where to get your IPv6 addresses. Now, just very quickly, if you already have an IPv6 address, can you please reply on the chat so I have an idea who already have them, or if I still need to look further or define this a bit further. How many of you already have an IPv6 address? Okay. Oh, no one. Okay. That's good because it's a good starting point that you come here to have an idea of that before actually proceeding. So the logical steps for, say, an organization when it comes to IPv6 is first, okay, a decision or a plan within the organization to implement IPv6. Okay, we are going to implement IPv6 in the next, say, 2 years or 3 years, or maybe in the next 10 years, hopefully not, but at least you have a timeline to follow that at this stage in our, say, upgrade process, for example, we will add in IPv6 support. So that is just an idea, okay, until you start like looking at, say, how do you actually get from this point where you are to actually implementing it. One of that is having people, of course, having network engineers who have an idea of IPv6 and who can implement it. So knowledge is important, training, okay, capacity building, so that you have enough people, okay, who knows what they're doing when they start implementing IPv6. What are the different requirements? What are the pros and cons? What are the implications if we do this? What are the possible issues that could happen and things like that. Okay, actually it's easier than that on a general sense, but obviously you have to take in all the possible issues or considerations that might come up. Okay, once you have that, of course, and the next step, or maybe you can do this in parallel with training your staff, is to get your IPv6 address. And where do you get them from? Depending on like what your network is like. Maybe you are working for a big corporation, or maybe you're working for an ISP. Maybe you're in school, or maybe you're, say, in an education environment. So depending on that, okay, you will get your IPv6 address either from a regional internet registry, RIR, okay, and we have 5 regional internet registries around the world. So you can see in this slide it says if you are an ISP, you have to obtain your IPv6 address from one of these regional internet registries, depending on which location you are, okay, and where you are operating your network or your business. Now, obviously, okay, most of you, I suppose, are from our region. So this is where you will get your IPv6 block from APNIC. So Asia Pacific Network Information Center. That's where I'm from. So APNIC provides and delegates /32 IPv6 blocks to internet service providers, or generally we call them as local internet registries. How do we define what's an LIR? A local internet registry is generally, say, kind of like, say, if you think of an ISP will have customers. Okay, so in a more general sense, an LIR, okay, doesn't exactly have to be an ISP, okay, but it will use that IP address to delegate those smaller IPv6 blocks to its customers. Maybe it's going to their different regional offices, maybe for their different campus units, okay, maybe for, say, maybe they have a worldwide deployment in a corporate environment, or you can be an ISP where you have different networks or different, say, POPs all over the country. So you get your /32 IPv6 block. If you already have an IPv4 address block, okay, it's actually very easy to obtain your IPv6 address. So if you have, depending on, say, you have an allocation, okay, an allocated block or an assigned block. If you have an allocated block, say when you say allocated in this case is same as my description earlier. Say an allocated block is a block that you don't exactly will use for your own infrastructure, but you will use that to delegate further to your customers. An assigned block, on the other hand, is a block of IP that you will use for your own infrastructure, for assigning to your own infrastructure. So that's the main difference between them. So if you already have an IPv4 address, okay, you might have to check that with your current networks. Okay, check whether it's an allocated space or an assigned space. And depending on that, you will get either a /32 IPv6 block or a /48 IPv6 block. So those two, obviously you can request for more if you think /32 is not enough for your case, but that is as a subsequent allocation. Say, for example, you have a /32 now. You've used, say, a significant amount of your /32, and you can look at that based on the HD ratio. If you meet a certain, we call it as HD ratio, then okay, you are eligible for a subsequent allocation, which is essentially the same size as your previous allocation, your first allocation. So if you have a /32 block, if you do a subsequent allocation later on, you will get another /32. And generally, okay, if possible, it will be an adjacent block. Okay, so you can announce it as a single bigger block, which is a /31. Okay, so that's how you generally get your IPv6 address. Now, if you are not from the APNIC region, okay, we have other RIRs, Africa for the APNIC, for the African region. For North America, we have ARIN. For Latin America and the Caribbean, we have LACNIC. And for Europe and the Middle East, we have RIPE NCC. So depending on the region that you belong to, you go to that RIR and request for your IPv6 address. So these are where they are located, so you have a visual understanding of that. I've already talked about this. How do you get your IPv6 address space? So I guess the important thing to retain is how much can you get? It's /32, or as I've said earlier, it can be larger if you need more depending on the number of customers or the number of assignments that you will do. Okay, in general, you'll get the same size as your previous allocation. Most end users, I haven't discussed this yet, for end users, so if you are not an ISP and if it's an assignment, if you want to use this for your own infrastructure, then you will typically get a /48 IPv6 block. So it depends. If you are an APNIC member, which you can, okay, and you want to receive an assignment, you get a /48 IPv6 block. Now, if you're not exactly an APNIC member, say if you are, say, a university, and then you have, say, an upstream provider, okay, provider A, and then you want to use IPv6 transport, you want to, say, experiment on some things in your lab environment, and you want it to go through via IPv6. So what you can do is request for physical connectivity via v6 to your upstream provider and request for the IPv6 address block from that same upstream provider. Generally, upstream providers will give you a /48 as well. Okay, so there is plenty of IPv6 address space if you think about it. One local internet registry gets a /32, but how big is /32? A single /32 block in IPv6 is equivalent to the entire IPv4 address space. Remember, we use 32 bits in IPv4. So one ISP or one LIR gets an equivalent of the entire IPv4 address space. Although obviously there will be, at this point, there will be some limitations and best practices on how you can use that IP address so that you don't end up like distributing very small, very tiny blocks which will overwhelm the global routing table later on. So for example, you have a /32 now. Can you subdivide that into /120s and then give a single /120, okay, to each of your customer? Can you actually do that? Can you announce it to the global routing table? There are obvious implications if you do that. So we will look at those things as we proceed in this class. Okay, let's look at addressing plans for a typical ISP infrastructure. So obviously, how much will you get? /32. /32 is the minimum allocation that is assigned, okay, or given from the RIR, in this case from APNIC. Address blocks for router loopback interfaces would be coming from the first /64. And then for each loopback interface, you are assigning /128. So let me just step back here a little bit. So you have a typical ISP network, ISP infrastructure. You have to check your topology. Okay, this is my network. Okay, then you design a plan, okay, on how you will assign your /32 block to each part of your network. So I guess the first part here is identifying what are the different parts of your infrastructure. Okay, which parts do you need to assign an IPv6 address to? So let's say if it's just your backbone, your network backbone, okay, then that might be easy. But do you now want to assign IP address to, say, end users? How much are you going to give to each department and things like that should also be considered. Now, in this case, let's look at the topology first, the infrastructure first before the end users. So, what are the different parts of your network in this case? Okay, think of a typical network topology. Say you have, okay, I don't know, you have a network, you have different POPs, you have distribution networks. Okay, from this, your customers will connect to your distribution networks. You have core network. Okay, how many routers or how many, say, distribution networks are connected to your core? Okay, what are the different parts or different elements, okay, or different devices that are in your core network? Okay, you have to think of that. Do you have data center? Do you have NOC? Do you have, say, different, say, servers located in different parts of your network, say, different subnets, and that needs IPv6 as well? So you have to consider all of those small pieces and tie them up together. Now, one important thing in IPv6 is, if, like, say, when you're just starting to design your network, okay, remember that aggregation is an important factor in IPv6. What is aggregation? Aggregation or summarization, okay, is when you can combine, okay, smaller IPv6 blocks into a single IP block and then announce that to the global routing table. Now, we do aggregation in IPv4, right? Even IPv6, aggregation is more important because I think I've explained it in the previous slide. Okay, if you have a big block like a /32 and then chunk them down into very small pieces, and then all of you announce it to the global routing table, okay, what will happen to all the routers? What will happen to the routing table and the amount of time that needs to converge and things like that? So it has a very huge impact onto the global routing table. So again, when you design, think of the different parts of your network and how you can aggregate them. Okay, so let's start with a typical infrastructure where you have a core network, possibly say let's have 2, 3, or 4 different regional networks. And from that regional network, you may have 2, 3, 4, or 5, or maybe more distribution networks. For each distribution network, maybe you have 2 or 3 different POPs, and then you connect your customers to those POPs. Okay, that's a typical ISP setup. So what are the different parts of that network that needs IP address? Obviously, each POP, each regional network will have its own. Your core network will have its own. The devices will have loopback interfaces, point-to-point interfaces, and things like that. Sometimes you have to connect to a transport link, so you need to have an IP address block assigned to them. So that's what we have here. The first part is for loopback interfaces. If you have, say, 100 different routers in your ISP network, okay, you normally will want to have loopback addresses for each of them. So if you have, say, an IGP such as OSPF or ISIS in that network, say you use the loopback interface to reach all of the routers in your network. So it says here that generally, okay, out of that /32, you pick out the first /64. So you have to do subnetting. From your /32, you have to, okay, subnet them into smaller blocks until you have the first /64. The very first /64, you get your loopback interfaces. Each loopback will be /128. Okay? Alright, another important thing to remember here, /48 is actually big. It's a big block. It allows for about 65,000 subnets if you're giving /64 to each of those subnets, right? So it's up to you. Generally, for a mid-size ISP, okay, for enterprise networks as well, /48 is enough. Okay, now if you decide to use your entire /32 block, okay, you can then use each /48 per region, one regional network. Okay, so you see how, like, if you're just like a small ISP, how that will be too big. One /48 for single regional network. Okay, so generally it's used for the largest international networks out there. /48 is used already for the entire backbone. Now, in most of our examples here, we will use /32 for our for overall block, and we will subdivide in two smaller, say /48s per region. Again, summarization is very important. In between sites, in between regional networks, okay, make sure that you summarize whenever you can. Okay, continuing with this, what about LANs, local area networks? What is the smallest block? Okay, what is the smallest prefix that you can give to a single network? What about if, say, I have different departments in my network, all of them are in different LANs, and then in one department I have 5, in one department I have 100, in another department I have 1,000. Maybe I have many, let's say, small devices that are connected in that network. So does that make a difference in how much I give to each of those LAN? Generally, no. Okay, because you can give a /64 to all of them. Now, if you think that's a bit wasteful, okay, that's kind of like a limitation that we have. I've explained this in the previous session. Okay, /64, that's the kind of like your limit, because that's where you do your subnetting. Okay, the last /64 bits will be used for your interface ID, for actual assignment to the host. So for your subnetting, /64 is the smallest prefix that you can give. So whether you have 5, 100, or 1,000 different networks there, okay, there's no real distinction onto the size of the LAN or the prefix that you will provide for each one. So generally, /64 per LAN. Okay, next one. What about point-to-point links? So obviously you have different connections between your routers in your core networks, connections between your regional network routers, connections between your, say, edge router and your customer routers. So those connections are point-to-point. We have to assign a block for that. How much do we give? Now think about IPv4. When you do this in IPv4, what is the best practice on this design? Okay, you need how many IP addresses? So point-to-point link is very simple. You have 2 endpoints. So you need 2 IP addresses. Therefore, in IPv4, we assign /30 for this point-to-point link. Why /30? It's for obvious reasons. /30, it's because you need 2 valid IP addresses, and then 2 of your other IP addresses, okay, are used for broadcast and network, right? They're your network address. So it's not obviously valid, so you need 4 IP addresses, so /30. Now, in IPv6, we don't have broadcast. Okay, that's the purpose of the other 2 IP addresses there. So all the IP addresses are actually valid. Okay, all the IP addresses in a subnet are actually valid. So you can assign actually a /127. Does that make sense? /127 because you need 2 IP addresses. Simple as that. You need 2 IP addresses for the point-to-point link. So based on RFC 6164, you can actually use that. But different people have different practices based partly on how they say they're used to with IPv4. Say for example, if you're using /30, okay, for those point-to-point links in v4, some who design their IPv6 networks based on their IPv4 network will use a /126. /126 provides you with 4 IP addresses. Obviously, you only need 2 of them, okay, because all 4 are valid, but so you only need half of that. But because you have that kind of a design in IPv4, IPv6 is patterned on that. So you use /126. That's also okay. That's up to you. Now another one is, this is generally what we do in our lab setup. We assign a /64 for the point-to-point link, okay? But for assigning to the actual interfaces, the point-to-point links there, we use a /127. The reason for this is simple. IPv6 is a huge block. You don't want to tie yourself with assigning very small /127s for each. When you do your plan, just give the whole /64 to each. And if you have issues later on, okay, you don't have to renumber your network because you've assigned a very small /127 block for that link. Okay, so it's kind of more flexible to do that. So we assign a /64, but on the actual assignment to the interface, we use a /127. Okay, so there are other options, other ways that people have been doing it. /126, I've already mentioned. /112, /80, /120s. So there's kind of like a healthy discussion over this in the community. Okay, now for customers, how much would your customer get? So again, typical ISP network, okay? Now you don't need to worry about like what you're assigning to your infrastructure, but what you're assigning to your customer. And what are the rules? Are there any rules? Are there any policies that govern this? The answer is no, except for the limitations that I've already told you about, which is /64 is your smallest block. A single LAN will use a /64. Okay, so you can't give smaller than this. Maybe you're thinking, okay, I have /32. So if I give /48 for each of my customer, what will happen? Okay, I can only have 65,000 customers. I am a very big ISP. I want more. Okay, I want to be able to give more to my customers, and I think /48 is actually very big for this particular customers. Maybe you have home users, okay, broadband users, and things like that. You think that that's too much to assign for that single customer. So it is now up to you. It's your decision to make, okay, based on your company policy, okay, maybe based on the subscription, based on whatever agreement that you have with your customer, you give them a certain block. But you limit that between /64 and /48. Now, I always mention this. You want to do your subnetting based on, okay, nibble boundaries, factors of 4. Okay, so in between hex values, so it's easy, it's less prone to errors. Okay, so everything is smooth when you do your assignments. So you work between /64 and /48. /48 is your maximum for very large N sites. /64 is what you give for those networks that only need a single LAN, a single network. Okay, but you also have to think about the future. So in, say, a couple of years' time, this customer might become bigger. They might need 2, 3, or 4 networks through 3 different subnets. So /64 again will not be enough for them. So I can assign /64 to them now, but I have some, okay, some available slots, okay, and this is like based on the strategy that you do when you assign. I have some available slots that are adjacent to that /64 so that when it's time for me to give another /64 to them, I can assign that adjacent block and he can announce an aggregated prefix. Okay, so that's going back to our original goal, which is aggregation. Okay, when you design, make sure that there is an option to, okay, for those customers to request for more blocks, and they can still combine that and announce as a single prefix. Alright, so I hope that's pretty clear with everyone. Alright, so what if the customer is bigger than a /64? I don't need one network, maybe I need more. Maybe in my small business, I need 10 subnets, or maybe more, 100. So work on the nimble boundaries. From /64, maybe the next will be /60, another /56, and so on and so forth. Alright, until you reach /48. Any questions? I saw someone typing in there. So just something to think about there. Okay, there is no real policy that limits you on the size you will give to your customers, but you generally work in between /64 and /48, which will be the typical case for an end user. So this is from an ISP point of view, right? And then you have customers. Customers are your end users. When you think of end users in this case, it is a network, an end user network, and we give either /64 to a /48. So if it's a very small end user, say you are providing broadband internet, okay, and each household will possibly typically just use one network, you give them a /64. Okay, but again, you have to remember future growth. Will this network grow in the future? Will they need more subnets? If they do, am I ready to give them another /64? Or maybe I should start now. I should give them /60. Okay, does that answer your questions, Leo? Okay, so typical case for end user, you start with a very small one, /64, /60, and so on. Okay. Moving on to the next one, for customer address assignments. This is just general advice based on our infrastructure. Customer address assignments should not be reserved or assigned on a per pop basis. So think about this. You have a network, so you're operating nationwide. Okay, you're operating in your own economies, in your own countries, and you have one in, say, the metro. Maybe you have one pop on the northern side of your geographical your island or whatever, and then maybe you have another one in the southern side or the eastern or the western side. Now each of these parts, okay, each of those maybe provinces or towns will have different growths. Some of them will grow far better, okay, faster. Some of them will just retain the same number of customers. So we're talking about customer size here, okay, which is relevant to or related to the population. So if it's a city, okay, there is a better chance that it will grow faster over a rural place. So if you assign equally among all of your pops, then one will grow bigger over the other, and you will need more IP address on there, but you won't have enough because you've used up everything, but you have way more in another pop. So what we're saying here is the reservation process, okay, if you are doing your design, okay, you don't assign them equally, okay, because you know that that's not going to happen in real life. They don't grow all at the same time. Okay, the number of customers that you get, okay, is not always the same for each part of your, say, your region that you're operating in. There's nothing new to this. It's the same principle as you do in IPv4. Okay, so just always like you can still keep all of those BCPs that you're doing in v4 in addressing in IPv6. Another one, ISP IBGP carries your customer networks, so you will be running IGP within your infrastructure. Okay, and that's why you generally assign loopback interfaces to them, and then aggregation is not required for IBGP, just for internal networks, but for eBGP, so the stuff that you announce out there, outside of your network, you must do aggregation all the time. It's necessary. Now, backbone infrastructure assignments, number out of a single /48, again, aggregate to minimize the size of the IGP as much as you can. So you want to operate your network in a simple way, aggregatable blocks easily. So you have to design your addresses and assign them accordingly so that you can do your aggregation properly. Okay, next one. Well, this one is just like a diagram of like what we would normally do, right? What we've discussed in the previous slide. You have a single /52 block. From that, okay, you subdivide them into /48s. You get the first /48 that will be used for your infrastructure. That should be enough for your entire infrastructure, really. And then get the first /64 out of that /48. That first /64 will be used for loopback interfaces. And what is the reason for that? It's actually purely, I would say, selfish reasons. The reason is because it's easier for you. When you're doing troubleshooting in your network, it's easier, okay, because you have assigned the very first block, which will have the lowest number of bits or hex digits in your IPv6 address. Okay, the one that you can summarize more. Okay, it's all in the very first block. So what block size do you normally get? So I'll give you an example, and we will use that same one later on. In our training, okay, we have a block. It's 2406.6400/32. Okay. Now, what is the first /48 block from that /32 block? Easy. You don't really have to think about it. It's 2406:6400:/48. You're essentially just changing the prefix there. What is the first /64 out of that block? Again, it's the same. It's 2406/6400:/64. So you get the very first /64, okay, and you use that for your loopback interfaces. Okay, again, it's easier for you to do troubleshooting. Next one, phase 2, if you need an extra /32 block, say you've already used all the blocks or most of the blocks that you have here. Notice this part here, all the /48s following my initial /48 will be used for customer assignments. Now, if I need more, okay, it's the same process. You just get another /32, combine them together, /31, that's what you will be announcing. But you can just use the same process. Get the first /64 or first /48 out of that /32 and use that for your own network, etc. Okay, some people would go and try to fit everything into this first /48, and all of that will be for your customer usage. That's also fine, so long as you have enough for that usage. Again, think about aggregation. Okay, any questions so far? Okay, so you get a /32. You have an option to double that if you need subsequent allocation later on, so plan accordingly. Let's look at some examples. This one, we're using the same prefix that I gave us an example just now, which is our /32 block for our training. Let's look at two possible scenarios, okay? Again, this is for reference only. Okay, this is actually kind of like simplified version of addressing. Okay, but it's a good start. Okay, you can use it as a starting point when you do your addressing. Your setup might be, I don't know, more complicated than what we have in these examples, but at least you have a starting point and you know what the practices are. Two examples or two case studies that we have here. Option 1 is for ISPs that are growing on their internet access customer. What does this mean? I have a growing population, okay? I have more customers subscribing to my business, my ISP. Whereas for option D here, it's not just your customer base, but also data center. So aside from customers using your network, using you as transit, okay, you also have, okay, like part of your business, you're providing, say, hosting. You have data centers. And where do you put those data centers? Somewhere in your core or your regional networks. Obviously, as it grows, it also needs to have its own IP address space, IP address blocks, right? So how do we do this? For the first option, okay, this might not be very clear to some of you who are just like using the app. But if you download this later on, okay, I'll give you, it's actually on the same link where we upload our PDFs. So you can zoom in and have a look at the blocks in more detail. So this is just it basically shows us how we do the subnetting. Okay, which are the important parts here? I'd like you to look at the block column, the prefix, and the description. All the others, while they're important, it might confuse you at this point. Okay, so I'll just explain them a little bit. Reverse domain. So this is the corresponding, okay, domain for your IPv6 block, okay, for your reverse DNS. The next one is SOR, second opinion request. Second opinion request is like if you have to assign smaller blocks out of the blocks that you've been given to you, do you need to contact or seek support from APNIC to be able to do that? If you are a new member, you actually have a very small, say, kind of like limit into what you can give without second opinion request, and it grows as you become more knowledgeable on how to do it, okay, or as you grow older in your membership. So generally, we don't do SOR in IPv6 except for very large blocks. So you'll see no or not yet in this field. So ignore that for now. And this one is registration, whether it's done via APNIC, your upstream providers, or it's up to you whether you want to register or put the information about it into the WHOIS database. Okay, so let's look at these examples, all right? So again, focus on blocks, prefix, and description fields. I have a /32 block. I named that block number 1, okay? And I'm going to subdivide that. This is my biggest block. Now, I'm going to have to think which parts of a network will need IP address. So this is option 1, right? I have a growing customer base, so I need to give a big chunk of IP address to my customer. So what I did here is divide my block into 2. So /32 divided into /33s. Okay, you have 2 /33s and a /32. What are those blocks? So that's subnetting. I won't go through the details of how you subnet, but after this session, I would encourage you to try it for yourselves, okay, and see whether you get the same answer. So /32 divided into 2 /33. You have 2406640/33 and 24064008000/33. Okay, the first tab is for everything: infrastructure, data center, customer point-to-point links, customer networks, and the rest here will just be for your customer networks. So what I did was look at the first /33 and then subdivide them into /48s. Okay, these are all the /48 blocks out of that /33. Actually, this is not all. There's more. Okay, but we cannot really list them down here because there's just too many. So these are the very first parts. Okay, so you get the first /48. You use that for your loopback, for your transport links, and for your point-to-point links. Basically, for your infrastructure. Okay, so from that /48. That's the first one here, block number 4. I use the first /64, assign it for loopback. Okay, that's our plan all along, right? We want the first /64 out of the first /48 of our /32 block. And then what I did here was, for the second /64, I didn't do anything. Okay, it's a reserved block that I will use later on just in case I need it. If my network grows in 5 or 10 years, I won't have to renumber. I have this reserved block that I can use as loopbacks, and I can combine this together, announce it as a /63. Okay, now the next block here is more for my transport links. Again, I have some space that I'm not using now so that I can use them for future use. And then the rest here is for my infrastructure WAN links. Now going back here a little bit, that's your first /48, right? Your block number 4. Now this next ones, you have 4 customer point-to-point links. Okay, CS P2P links. Now our topology here is actually using 4 different regions. Okay, that's why we do this like this. So /48 for each region. And then each region also has its own data center. What's the data centers have to do with the ISP? Well, for obvious reasons, that most ISPs also provide different types of services to their customers, whether it's hosting, web hosting, maybe DNS, mail, etc. Okay, so you have those data centers, and you don't just store them in one part connected to your core network. Usually, you distribute them to regional networks so that it's closer to the customers who will actually use it. Okay, so again, we have 4 different regions in this case. So our data centers are located in those 4 regions. So we assign 4/48 blocks for that particular purpose. Now the rest here will be used for our customers. Okay, so that's the first block. Now the second block, the second /33, is mostly for customers. Okay, we subdivide them into /48 blocks, and then okay, that's the blocks that you give to each of your customers located in, say, region 1, region 2, region 3, and region 4. Now in this case, we have a very huge block /48, so we did not actually bother on reserving an adjacent block. But let's say, for example, customer 2 is a mid-size organization. Okay, I don't want to give them a /48 because I feel like it's too big. So what I can do is still reserve this /48 and then subdivide it further. Maybe I'll subdivide it into /56s and then assign or give the first /56 to that customer, okay, but reserve the rest. So this entire /48 still goes to that customers should they need it in the future. But right now, they get a /56. Does that make sense? So that's a decision that you have to make for yourselves. Maybe you want to give the entire /48 based on the subscription tier for these customer, or maybe for this subscription you only give /56s, but if it will have an impact on you or your network in the future, okay, you might want to still reserve some of those blocks, even if right now you're giving smaller than /48. Okay, so think about your future growth. Any questions for that example? It's actually very easy. Okay, all you need to do is kind of like follow the train of thought that goes through the design process for that. Now, option 2 here is you have both data center hosting and internet access customers. So it's a bit of a different approach. Instead of subdividing them into /33s equally, here we decided to subdivide it into use the next level. So from 32, you have 36. So we subdivided into /36 blocks. Question for you. How many /36 blocks are there in a /32? Okay, so you have them here. Okay, so that's 2⁴. Okay, so what we did was for the first /36, that's the only one that we're using for our infrastructure and for everything else. And then all these /36 blocks goes to your customer network. The first /36, block number 2 there, we subdivide them into the next level, /40. And then first /40 again goes to our infrastructure. Okay, the others here, the rest is for our data center. Why are we doing this? Remember, we have to give focus on data centers in this second example. In the first one, it's just very small /48s, remember, for each data center. Here, we're giving /40 for each customer, or for each region, for each data center essentially. So if we have more regions, if we grow bigger in the future, we will have more here that we can give them. Okay, but right now, because we are expecting it to be bigger because of the growth, okay, we assign /40s and instead of /48s. Okay, now for the first block here, this block number 18, okay, I subdivided that into /48s. Okay, that's your typical /48 block. Okay, and remember, you have your customer point-to-point link, but it's /48, so you can still further subdivide that. This is essentially for one region, that's /48, and then divide that into smaller /64 blocks. So we came to the same kind of like very similar conclusion at the end here, okay, except that the block size that we're now allotting for our data center and for customer are kind of obviously we still assign more for our customers, but we put more effort into providing more IPv6 blocks into our data center as we have in the previous example. Okay, so you can easily do this. You can easily also pattern from your IPv4 setup. The thing is, the very first point is you have to know which parts of your network will need an IPv6 address. For hosts, for example, so you're an enterprise network or anything that's connected to your ISP network. Do you need to assign IPv6 address to each and every one of those devices? Say in a typical, say, organization company, okay, you have different departments, so obviously you might want to assign separate /64 or /64 blocks to each of them. But what if there is one tiny bit of that network? Maybe it's a network printer, and it's an old printer, it's legacy, and it doesn't have support for IPv6. Would I bother assigning something for that? Maybe not. Okay? Or maybe some parts of your network, they don't really want to or need to have IPv6 for local networks. Then, okay, you can also just avoid like assigning anything to that stage. Maybe it can be for different sort of reasons. Okay? But what I'm saying here is, especially if you're just starting with this, okay, you don't have to assign to everything, okay, but you must have in your design, okay, you must have that allocated blocks so that you can easily, okay, use that wherever needed in your network, and you can still aggregate. All right. So that's it. That's the example that we have there. These are just some addressing tools that you can use if you don't have one yet. They support IPv6. Okay, not net. For example, is actually quite popular, especially in the US, because it's built and operated by the University of Oregon. We also have these two projects. I'm not sure if they're being maintained yet. I haven't checked recently, but there are some of the few good ones that are out there. Now, most big organizations will definitely have their own, maybe built in, okay, in-house, or maybe something that's sourced out from a private developer or provider. Now, the thing is, if you already have that, I think the question for you is to check whether it has support for IPv6 or not. Right now, I think most of them will do, but if you're still using an address management system that doesn't support for IPv6, then you might have to rethink your choices. Maybe you'll have to double check with them when they're planning to do it, or whether they're actually planning to do it. If not, then find other providers that can. Okay, so that's the end of this session. I didn't really receive a lot of questions, but if you do have more, please ask them on the chat. Okay, so that was just a follow-up from Elia there. Okay, So the link to the survey is over there. I'm also gonna put that link onto the chat just in case you want to get to that. Just grab that quickly for you. Okay, so that's the link to the survey and the link to the materials. If you want to look at this more clearly, I think it will be a nice exercise for you as well for submitting. So this is the FTP page where you can download the slide handouts for this presentation. Okay, are there any questions? None? Well, I do hope that it has been informative for you. Okay, I hope it's not too much. But if you have any further clarifications, you know how to reach us. Please feel free to send us an email or chat or post a comment on our different streams. So thank you very much, everyone, for coming into this session. I have another one coming. I can't remember. I think it's transition or overview. But if you already attended this or already familiar with that, then that's okay. But if you find these last two sessions a bit difficult and you want some more, I don't know, basic stuff, okay, then please attend that next session, which is IPv6 overview. All right, thank you again, and I hope to see you another time. Bye-bye.